one of the if you want to copy a string, you actually need to copy quite a few bytes in memory. And the different processors, the ARM, the Intel, the RISC-V, they all have instructions to do that very quickly, to do block moves of memory. But they need to make sure that the source and the destination does not overlap. If the source and the destination overlaps, then you end up with a problem, because sometimes, depending on how you copy things, you need to copy from the end or you need to copy from the start. So that means that the processors, even though they have instructions to do copies very, very quickly, they cannot really use them, because it would be too expensive for every check to, or often they cannot use them because they cannot prove that the source and the destination do not overlap. So by making the strings immutable, that means there can be no pointer that could change any of the string inside. So in that case, the compilers can always use the fast move operations. Another reason is that if you have constant strings, then the computer doesn't actually need to store them as strings. It could just store the hash value and use that for comparison and things like that. That's also commonly done by compilers nowadays. So it makes for more efficient programming if you do not if you make strings immutable. In most cases, the program will run faster. Sometimes, if you do actually need to change something, the program will run slower, but most of the time we don't do that, or that's not the most common case. The most common case is that programmers themselves don't change strings and they keep them immutable. Now, if you actually do need to change the string, though, from A, B, C, D, E with a capital C to all lowercase, then you have to create a new string. So you could say that the string is from 0 to 2 plus a C plus the string from 2, 3 to the end. And then that will print out A, B, C, D, E. But here I actually need to create a new string. This generates a new string saying take the first part, add a C to it, and add the tail to it. This can be also quite an expensive operation. So if you do this very often, then you probably want to change your program logic so that you don't have to do that so often, or you want to deal with those strings as lists. Another way you could do that would be I think that's it. this one you wouldn't use, you cannot use string in this case. You can do this dot join L. That's another way of doing it. This one is not so common though. So you can deal with strings as lists and then join them after you're done with them if you do need to modify things. But most of the time I just use this style. Because whatever you do, you have no choice. You have to generate a new string. So then let's have a look at the last part, which is conditionals. So we've looked at list manipulation. And since we're dealing with immutable data structures, let's just finish them off. Sometimes it's useful to have immutable lists, so lists that you can change. Those are called tuples. In Python, and you can create them using round brackets instead of square brackets. Then will fail. All other operations on lists work the same. So sometimes if you want to have an immutable list, then you can make it a tuple, and then all the indexing, all of that will be the same. The only difference is that you then have you won't be able to overwrite the values in the list. So let's skip that part. Conditionals in that's one of the third part of imperative programming. So conditionals allow us to change the control flow based on some external signal, some input from the user, or some other state of the program. In Python, those are done using if, else or else. Like most programming languages, Python is almost identical to other programming languages there, apart from the else if, which I'll explain in a second. So let's have a variable x is equal to Joe, and if x is equal to Bob, then print Bob arrived. So I can write program like that. X is Joe. If x is equal to Bob, then I can say Bob arrived. Otherwise, I say I don't know user X. So then it'll print out Joe or Tom. Right? It'll print the same thing. So now that's okay, except if I now have many more users, right? Then my next line would be something like, if X is Bob, I say Bob arrived. If X is Joe, then I say Joe is here. Else, I don't know this user. Right? So that's correct. That's valid Python. But the problem is, if you look at that here, then the else has a colon after it, right? So that means this part, this if, must be pushed in, must be indented by 2 spaces. So now I have another if here. So that must be indented by another 2 spaces too. So you can see, if you have to check for 10 users, then the code will shift all the way to the right, so it'll be hard to read. It'll be all in the rightmost column, shifted across the screen, so that doesn't make it look very nice. Usually a rule of thumb for programming is that if you are nested more than 3 levels deep, then you should probably start thinking about extracting some of that logic as a separate subroutine or function. So we don't want to do that over and over, shifting it, and that's why we have the else if keyword, which allows us, it does exactly the same thing as this construct, except it means that we don't have to shift to the right. So here I can do else if in one line, and then the indentation will remain the same. These two programs are identical. So this is exactly the same program as above, but no increase in indentation, which is nice. We also have logical connectors. So you can say if X is Joe and X0 if x 0 to 2 is equal to j and o, and x minus 1 is equal to e, then it would think that it's Joe, but I can also set it to Joanna. Right? And it'll say Joe is here, but in that case, of course, or anybody else that starts with J-O and ends with an E, they will all be accepted under this branch then. Or we can change it to or. So this is not a Y, then it will also match. So you have and, or, and not. Same way that you would have in other programming languages in order to create more complex conditionals. So here's the same idea with numbers, and we have the Boolean connectors. So now the last part that you need to know in order to become, at least start to become proficient in programming in Python, is how to structure your program. At the level that we're dealing with, that mainly means functions and subroutines. So to define a function, you would say def keyword, and then you can have a list of arguments, argument 1, argument 2, argument 3. The arguments can have default values, so 42, for example. If I don't specify argument 3, then it will take the value of 42. If I call function with 1 to 12, then arg3 will be 12 instead of 42. I can generate a result variable and then return the result. So given this program, let's have another quiz to make sure you guys have not fallen asleep yet. Generate one input, one function call, so that your program will return 42. Oh, sorry, that's wrong channel. Let me post it here. So post your solutions in the artificial intelligence channel. Hello, you guys can still hear me, or are you all asleep now? Okay, good. Then please answer the question. So if I call 1, 2, 3, then what will the output be? Not surprisingly 6. From -5, I get -5, 2, 3 will give me an output of -5. So how do I get 42? Or what did I ask? 42, yes. So what do I have to call function with in order to get an output of 42? Well, different things I could do. 10, 10, 22 will work. Yes, nice. So that's a good solution. Okay, don't write a function. You're supposed to call this function, not write your own function. Okay, and once you found one solution, now let's play Python Golf. What is the shortest program to generate an output of 42. So 10, 10, 22, I would count that as 3 plus 3 plus 2 characters. So that's a total of 8 characters. So now can you make it smaller? 14, 14, 14. Yes, correct. So that's also 8 characters. 1140 is better. That would be 1, 2, 3, 4, 5, 6 characters. Yes. Any way to make it smaller? What are they printing now? 1 minus 1. Nice. Yes. That will do the trick. And that would bring it down to 4 characters. And I think that's the best you can do. 1, 2, 39 is also correct, but it is 1, 2, 3, 4, 5, 6 characters. Another possibility, of course, would be just this, right? 42, 0 will also work. Sorry, no, that won't work. If it's greater than 0. Yeah. No, delete this one. Wrong. So I think the 1 minus 1 is the... no, actually it's not. You can do even better. So this one is almost optimal. Function 1 minus 1, but you can actually make it better. You can make it smaller. Can you? No. No, maybe not. Maybe I was wrong. Yeah, I think the -1 1 is the best you can do, because it must be greater than 0 and you need to get 42. So characters is the number of chars in the string 1 minus 1. So you can find that out. You can print out length of 1 minus 1 in Python, and it'll tell you that that's 4. And we need to have something greater than 0. Otherwise, yeah. So I thought there's maybe but there's no other trick to get the -1 that you need. So the best you can do is 1 minus 1. Which gives you output 42. That's what we want, and it uses 4 characters. And the previous solution here would have 6 characters, or 8 characters. So 10, 10, 10, 22 has 8 characters. Yes. The 6 characters, because function all the same, right? That cannot change. Since function bracket, close bracket is always the same, that doesn't change. So everybody will have those characters. Okay. So we use that to break arguments into, to break our program up into smaller units. Python also, and we'll use that extensively, but only using external libraries. We probably won't be writing our own modules, but you can also have what's called namespaces in C++ and Java. In Python, they would be called modules, and they allow you then to break larger components up in a program. So if you want to have certain functionality, so let's say you implement a library to do graphics, to draw windows, then that may be in the window module, and then you would go like import window, and then you can use all the functions from that particular module. That then requires you to structure your program correctly. You need to have a folder, a directory called window, and you need to have certain files in there. we don't need to use that for this course, but we will import some libraries and then use them in order to be able to do some scientific computation and some machine learning in the course. So here, let's say, have a look at a couple of functions. Here's a very simple one. It prints the number, a function that counts the number of characters that are in a particular set. For this, in Python, it's quite nice. We have the in function, which checks if a particular element is inside of a list or not. So this function, count chars, actually I should change that. Python sort of changed between version 2 and version 3. The more Pythonic way now is to print this using snake case instead of camel case. So let's try and stick with that. So hello world, if I set fset to O, just the string O, then here we initialize the count to 0. Then for every element in the message, so now this will be H, then E, then L, then L, then O, then space, then W, then O, then R, then L, then D. It checks if that element is inside of my set. Then I add 1. So hello world O will return 2 because there's 2 O's here, right? O in hello, 2 O's. 1 O, 2 O's. And actually here, now we're looking for A-E-I-O-U in this string, but only the lowercase version. So we have 1 U here and we have 1 A here, so this will also return 2. So this is actually not so nice. Let's change this program. For strings, there's many different functions that you can apply for strings. One of them is lower, which will convert the string to lowercase. And now we set our case, now it will count 4 because I will now be converted to a lowercase I, which will match here. And U will also be converted to a lowercase character. So that kind of counting loop, counting occurrences of elements, is quite common, quite useful. We have to do that quite often. In particular here, this line is of interest because we're checking if this element exists in this set. So the in function is very useful in Python. So now let's do another exercise. So I want you to write a function that takes a list as input and has a set that we're interested in, 1, 2, 3, 4 in this case. And then it checks if every element of every element of that list is included in LST. So here we're looking for 1, 2, 3. So we have 1, 1 here, we have a 2 here, and we have a 3. So this will return true. This should return true. This one, 1, 5, 4, 5, we have 1 is here. We have 5, which is here. But we don't have a 2. The 2 is missing. So this will return false. So see if you can implement a function that will do this correctly without looking at the solution, of course, first. So I give you 5 minutes to try and solve this. Try and implement a Python function that will return whether a set includes all the elements or not. And let's call the function check includes. Again, you should have installed Anaconda by now, so you have your own Python environment. You can use any editor, Visual Studio Code or Idle or Spider or PyCharm to write your own program, and then try and see if you can figure out how to solve this particular question. Okay, good. So how are we going? Any solutions yet? Okay. Then give you a little bit more time. If you have a solution, you can send it to me on the Artificial Intelligence channel. Well, then the solution is actually not that difficult, except I want to flip around in which way I check. If you look at the count, then we're iterating over the characters in the message. And here, because I need to count each and every one of them, here I just need to check if that character or that element exists in that list at all. So I iterate over fset instead of list. So for every element in my test set, if that is not in the list, then the result is false and break to break out of the loop, and then I can return the result, and this is the solution. That was the solution before I changed things. Right, so here's my answer. You can see if I don't allow you to use in, then that becomes more troublesome, right? Then I have to actually calculate that in myself, which means I have to assume that I didn't find the character. Then I go for every element in the list. If the two are equal, then I say I found it and I break out. And if I didn't find it, then I have to return false and break out of that loop. So this part here is nicely replaced by the single line here in the previous program. So in is quite a powerful, useful function in Python. So here we can also have different ways of accessing the list. First one, if you use range, then you get the indices, the numbers. You get 0, 1, 2, 3. If you use for I in the list, you get the actual values. So always be aware of whether you're actually using the index 0, 1, 2, 3 to n-1, where n is the length of the list, or the actual values A, B, C, D element 1, element 2, element 3, whatever you store in your list. Sometimes you need to know the index. Sometimes you only need to know the element. So far here, for example, we didn't really care about the index, right? For our message here, we didn't care about the position of the character. So I only cared that the character was in the string, but I didn't care if it was at position 1 or 2 or 3 or at the end or something else. Sometimes we care about the position of the character. Then you want to use for I in range, length of the list usually is most common. Some more examples. Sum of all the even integers in a list. See if you can implement that function. So here I have 1, 2, 4, minus 2, 3, minus 11. The sum of all the even integers is 2, plus 4 is 6, minus 2 is 4, and that's the output. So see if you can implement that function in Python. Try it yourself on your Anaconda installation. So here we have sum even. We can run a list. And first, what I generated oh no. Okay. So here we were summing all the even integers. That's actually not so difficult, right? Here I'm going to write a function first to generate a random list of integers. For that, I import a module called random, which gives me a whole bunch of functions to generate random numbers. I want to have n elements that are randomly selected between min and max. So this loop here starts with the empty loop, generates a random integer between minimum and max, and then appends it to the list. So at the end, here I get 5 random integers between -9 and 10, for example. And actually that should be 9 here because the max is inclusive. So then I can generate a list. So 2, -6, 4, 2, 3. It will give us some random numbers. And here's my solution for sum even. It simply iterates over the list for L in the list. If L is a modulo 2 is 0, that means it's an even number. Then I add it to the sum. And then once I added them all up together, I can return them, the sum. Oops. So I generate 3 test cases. So the first one, -2, -4, -6, -7 is odd, 7 is odd, +6 is 0. So this is the correct output. 9, 5, -8, -4 is -12, correct. 6 plus 8 is 14, plus 2 is 16, right? So now let's make this a little bit more interesting and sum up all the even numbers that are following an odd number. So for example, 1, 2, 4, 7, -2, 3, -11. Now I want to sum up all the even numbers, 2 and 4, for example, and that's it. But in that case, only if they follow an odd number. So this 2 is after an odd number, so that's counted. The 4 is not counted because it follows an even number. 2 is even. So this doesn't matter. And then the -2 follows an odd number. So I have 2 minus 2. So the output will be 0. So to implement that, here now, I do care about the position of the elements because the elements have to be the previous element has to be an odd number, the current element has to be an even number. So now I want to iterate from I, but I don't want to start at 0 here. So my start value is 1 because I need to look at the previous number all the time. And going to the end of the list, so that's the length of the list. So if the current number is even, so list I modulo 2 is 0, and the number that's at position I minus 1, the number that's at position I minus 1, if that one is odd, only then do I add the two numbers together. Do I add it to the sum. So then I get 0, 8, 2, 1 minus 5 gives me 0 because this is even, but it doesn't follow, there's no number before, so it doesn't follow an odd number. This one is even, but it follows an even number. This one is even, but it follows an even number. This one is odd, so it doesn't count. This one is odd. So no number is counted there. Here we have minus 9, so that's odd. This even number follows that odd number, so it's 0. This one follows an even number, so it doesn't matter. This one is odd, this one is odd. So we end up with 0 again. And here we have 5 is odd, 7 is odd, minus 5 is odd, minus 7 is odd. 0 follows the odd number, so it's added, but 0 plus 0 is 0, so we end up with 0 here. So let's run this again to get slightly more interesting output. So at least now we get 1, 2, because this 2 follows an odd number. Right? So it's counted as 2. This is even, but it follows an even number, so it doesn't matter. This one is even, but it follows an even number, so it doesn't matter. So our final sum here will be 2. So in this case, I do need to know the position of the element so that I can check for the previous element. Also, I have to make sure that my index is always in the correct range. This is actually a very subtle bug that would occur here. If I put 0 here, then this will not actually crash, but it will give us the wrong result. Because for this line here, right, the correct output should be 10 is even by its first value, that doesn't matter. 3 is odd, doesn't matter. 6 followed the 3, so it should be 6. 8 follows an even number, so it doesn't matter. Minus 1 is odd. So the correct output should be 6. But the output that my program generates is 16. So that is wrong, right? That is incorrect. So now, why is that incorrect? Well, the problem is that when I start, I is equal to 0. So list I is even. So this 10 here is even, right? 10 modulo 2 is 0. So it's even. And list of 0 minus 1 modulo 2 is not even. But 0 minus 1 is minus 1. But -1 for a list index actually is legal, and it refers to the last element. So in that case, we're checking if the last element, for the first step in my loop, I check if the last element is odd, and then I add the number. So this is why that program generates an output of 16 instead of 6, which is what would be correct. Right. So this is a very tricky bug to find. If you get this wrong, it will take you a while to figure out what the problem is. Anytime you're using I-1 or something like that, you should be careful to make sure that you're not underflowing, that you don't get a negative value there. So 1, I want I to start at 1, not at 0. And then I will get the correct output. It is also possible to do that without using another style of programming or another way of solving that same problem. Is by iterating through the elements and looking at what the previous element is. So sometimes you can follow this style too. The tricky part here is that then after you do your processing in the loop, you need to set the previous element to the current element. And then you go round and round. This code is also correct. Depends on the situation which one is easier to understand or whichever way you want to attack that problem. Just to give you another option. Okay, good. Then I want to start on dictionaries and finish them off today. They are actually very powerful advanced data structure. They are very useful, or they are efficient key value stores that you can use. So they're indicated by curly brackets. So I can say that money, for example, people that I owe money, so or that owe money to me. So Tom owes me $12 and I owe $5 to Mary, and Bill owes me $3 and Sally owes me $1. That I can store in a dictionary. I can also do, they don't all have to be the same thing. So I can say like this. So Bill has a list and Sally so I can store information like that. So I owe Tom $12. Tom owes me $12. I owe Mary $5. Bill owes me $3 and 10 Taiwan dollars, and I don't know who Sally is, for example. So because Python is a dynamic programming language, I can have different data types associated with each key. And in fact, the keys don't even have to be the same data type. So I can have some key that is an integer, for example. 0. If you're used to different types of programming languages, then dictionaries are hash tables. So access to this data and insertion and deletions are very fast. They are an associative store that allows us to associate a key with some data that we need to access quickly. I use the bracket notation in order to get the value, bracket notation with the key. So print how much money I owe Tom would be like that. And money 1, 2, 3 would be a different key, right? 0. So here we have another example with different keys and different data. In order to iterate over a dictionary, then I can get the keys by using the in function. And that's the simplest one. It's also the simplest one to remember. So that will, in any arbitrary order, it will give me the set of keys then that I have for this item, for this dictionary. So first key is Sally, and money of Sally is 1, and second key is Tom, and money of Tom is 12, and money of Mary is 5, money of Bill is 3, money of Bob is 12, and money of 12 is Tom and Bob. Something like that. So we can use this in construct in order to iterate over the keys. There's also some more powerful functions for dictionaries, but most of the thing that we do, this one is good enough. So if you want to write a function, for example, that counts how often a character occurs in the message. So here we have a message, TGH, HGTYSG, and you want to print out that there's 2 T's and 3 G's and 2 H and 1 Y and 1 S. Then dictionaries are the correct data structure to use that. And here would be a function that actually does that. So here I create an empty dictionary. I go into the message. If the element of, if the character is not in that message in that dictionary, then I set it to 0, and then I increment it by 1 because I found it. And then I can print out the count the way that I printed it above. And then I can also format the code. So this then prints out the counts for the different characters in this string. The quick brown fox jumps over the lazy dog, and let us just check that. That string is famous. It's used in lots of communication lines as a test string because it includes every character of the alphabet, or at least it's said to include every character of the alphabet. We can test that. And one thing we can do in our program, we can return more than one thing from a subroutine. So that's also quite common, that returns a tuple then. So here I can return the counts that I have as well as the string that I generate. So two things. When I call my function, I can say that the first thing should be assigned to variable message. The second thing should be assigned to variable mdict. We can run that. Now that gives us 27 characters. And all the characters that we have are from A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, X, W, X, Y, Z. So every character in the English alphabet is included. The reason why we have 27 is because it also has a space, it counts a space character there as well. So this is one English sentence, a short English sentence that you can form that includes every character. So for example, if I buy a laptop, then I often type that on the keyboard to see if I like the keyboard or not, because it forces you to type every character on the keyboard. And here's my JSON function then. This just wraps it so that it doesn't go too far, like it breaks the string up. So for that kind of key value store, dictionaries are the perfect choice. Also very fast and efficiently implemented in the Python standard runtime, so you don't need to import anything special. There's other complex data structures, in fact quite a lot of them, that you can use in Python. However, the basic lists and dictionaries are quite powerful. So unless you have very specific needs, in which case you probably know what kind of data structure you want to use, red-black trees or AVL trees or priority queues. Unless you know that that's a kind of data structure that you must use, most problems you can solve efficiently just using the built-in lists, tuples, and dictionaries and strings. It's really quite amazing how well the basic Python language works on its own. We'll talk some more next class about the scientific computing aspects of it. For drawing graphs and doing visualizations and things like that. There is the matplotlib and the NumPy libraries, which are also extremely powerful, but they are more advanced topics. So we'll discuss those a little bit later. So that brings me to the end of the class for today. As I said, tomorrow I'm busy, so we won't be able to